This video corresponds with the second lesson in Unit 4B, which talks about how to rationalize imaginary denominators. Back in Unit 4A, you learned how to rationalize denominators that had radicals in the denominator, in which you can't have a radical in the denominator, so you have to get rid of it, hence the rationalization process. You're going to see with imaginary denominators, it's the exact same idea. You're not allowed to have imaginary numbers or that magical I. You cannot have that in the denominator, so we have to get rid of that the same way we did in the previous chapter. So we're going to take a look at a couple of examples here in which you have just a pure imaginary number in the denominator, like you see in 1 and 2, and if you have a complex number, like in numbers 3 and 4. So, number 1 and 2 here, you've got a pure imaginary number, so it's just 5i as your denominator, number 1. We see 6i in number 2. So, in both these problems, since there's only one singular term, there's only that one pure imaginary number, all we have to do to get rid of the I in the denominator is multiply by I over I. Keep in mind, I over I is just a fancy way of saying 1. Multiplied by 1 doesn't change the value. It just merely changes, in this case, the look of the problem. So all I have to worry about is the I. I can put the 5 with it if I want to. I'll just have to simplify more at the end. So I'm cutting that step out by just simply multiplying by I over I. Then it's just a matter of simplifying your fraction. So 3 times I at the top will be 3i. 5i times I in the bottom gets you 5i squared. As we talked about in the previous lesson, if you have I squared is the same as having a negative 1. So I'm going to go ahead and replace any I squareds with a negative 1. And that'll leave me with 3i over negative 5. Means the exact same thing, but I've removed the imaginary part of the denominator out. It does shift to the top. Again, in the numerator, you can have all the i's you want, just like in the previous chapter. All the radicals you want can be up top. They just can't be in the bottom. Second example, exact same idea. I have negative 7 over 6i. I'm going to do the exact same thing. I just have that one term in the bottom. Let's get rid of the I by multiplying by I over I. So I'll have at the top negative 7i over 6i squared. Again, anywhere I see an I squared, I'm going to replace with a negative 1. So I'm going to have negative 7i over negative 6. This case, I have a double negative, one on top of the other, so they'll cancel out, which leaves me with a positive 7i over 6. So when it comes to rationalizing imaginary denominators, again, when you have the one singular term, the one pure imaginary number, I over I will take care of that in the denominator, and life is good. Numbers 3 and 4, however, you'll notice you have complex numbers. And remember, a complex number has that real component and an imaginary component. We saw this back as well in the last chapter when we had numbers that had some sort of integer component and it had the square root component. You couldn't just multiply by the square root. You had to multiply by that entire denominator using something called a conjugate. This is going to be the same process here with imaginary numbers. I can't just multiply by the I. That's not going to get rid of it in the denominator. It's just going to move it. So in order to get rid of it in the denominator completely, I have to multiply each of these final two problems here by the conjugate. So again, the conjugate of when we're dealing with these numbers here, if I look at the denominator of number 3, it's 1 minus 3i. I'm going to multiply by its conjugate, which is 1 plus 3i. All I'm doing is flipping the sign in the middle. So if it's a minus, we'll change it to a plus. You have to have the opposite sign as your conjugate, because when you multiply stuff together, it's the only way that'll get the imaginary part to cancel out. Once you're here, we're going to do lots of multiplication. So the 2 is going to get multiplied everything in the top, and then you'll see in the bottom here, we'll do some double distribution and get all of our terms together. So in our numerator, we'll multiply the 2 in. That'll give us 2 plus 6i over, now I'm going to go ahead and multiply my denominator together, so I'll multiply the 1 first. So 1 times 1 is 1. 1 times 3i is 3i. Now we'll multiply the negative 3i to the terms. So negative 3i times 1 is negative 3i. Negative 3i times positive 3i is negative 9i squared. So if I look at this, I'll notice in my denominator, positive 3i, negative 3i cancel. And I can also reduce this a little bit Remember, your I squared is the same thing as negative 1. So I could have 2 plus 6i over 1 minus 9 times negative 1. I can simplify a little bit further, be 2 plus 6i over 1 minus 9 times negative 1 ends up being 1 plus 9, which is 10. This is a pretty good answer, but if you notice, all the terms that we're dealing with here are even. So I'm going to go ahead and divide a 2 out of every single term and be left with 1 plus 3i over 5. So again, it's a similar process to what you did in the last chapter. The goal is to make the I disappear in the denominator. If you multiply by the conjugate, that'll happen every single time. It's just a matter of making sure you multiply all your terms correctly. The last problem here in number 4 is the exact same idea. So again, we're going to multiply by the conjugate of the denominator. So the denominator is negative 4 plus 2i. My conjugate would be negative 4 minus 2i. Again, the only thing that changes is the sign in the middle. Any other signs, so with the front term here, the real part of that expression, that negative 4, that's going to stay. So once again, we're going to do lots of distribution. And you'll see double distribution here for both sets of terms, okay, for both the numerator and the denominator. Just got to take your time, multiply everything correctly. So let's take care of the numerator first. 3 times negative 4 is negative 12. 3 times negative 2i is negative 6i. Negative I times negative 4 is positive 4i. Negative I times negative 2i is positive 2i squared. Now for your denominator, negative 4 times negative 4 is 16. Negative 4 times negative 2i is positive 8i. 2i times negative 4 is negative 8i. 2i times negative 2i is negative 4i squared. So again, a couple of things we'll notice right off the bat here. I can go ahead, 8i, negative 8i in the bottom is going to cancel out. You'll notice in the numerator, I've got more things that I can simplify, as well as the denominator. So we can do a couple of different things here. So my numerator, I can make negative 12. Combine the regular I terms, becomes negative 2i. And I can go ahead and start converting 2i squared into 2 times negative 1. All over 16. The 8i and the negative 8i cancel. Minus 4. It's an I squared, so once again, that becomes a negative 1. So I simplify the stuff in the top. Negative 12 plus 2 times negative 1 could go together. That'd be negative 14 minus 2i. Over 16 minus 4 times negative 1 becomes 20. Again, pretty good looking answer, but I can simplify that a little bit further because everything's even. I could divide a 2 out of every term, and that'll leave me with negative 7 minus I over 10. So again, when it comes to rationalizing imaginary denominators, it's a very similar process to rationalizing denominators that have square roots. If you have a problem like 1 and 2, where it's one singular term in your denominator, multiply by I over I, it'll clear it out every time. If you have a problem like 3 or 4, where you have a binomial, you've got 2 terms in your denominator, you have a complex number, you have to multiply by its conjugate, and simplify from there. And that's how you go about rationalizing imaginary denominators.